Greetings, students. It is your dynamic duo back again for the final phase of our laboratory for this year. This is going to finish off our work on solutions and equilibrium, and then looking at some of those effects on climate change. Okay, so hopefully you guys enjoy our little mini lab here today. And again, this is something directly relatable to stuff you guys see in news and such. Going on about climate change and specifically ocean acidification. Okay, so Mrs. V, anything to add?
Nope, it'll just be fun as you guys are learning about the whole cycling that we talked like in biology. We learned about how all the gases, you guys learned about how the gases cycled and energy cycled. This is now getting into what happens when that carbon dioxide comes back down, dissolves into our oceans, and what it affects. And so this is even something, as you watch Mr. Herzog and I do it, you guys could try at home. You don't have a pH meter, but you can see how the increased CO2 actually could affect shells.
All right, and that's basically what we're going to look at. Bring this into play here. Okay, what you see here is our little makeshift shell that we created. Yes, we spent hours and hours laboring to create this for you. Okay, so you can see this is a little shell. And Ms. V, you want to explain how we made this?
So this is, you guys have learned a little bit about carbonate. So this is actually baking soda. And we just mixed it with a little bit of water, kind of made a paste, put it in a mold, and it pretty much is modeling the shell. So this is just baking soda and water. Has a lot of carbonate in it that we have usually in the shell. So we'll see how this CO2 affects it.
Alrighty. And also, guys, we're going to cycle back and forth between a little graphing application. So what we have is a probe here. Okay, this is a wireless probe. Some guys, as you go on and pursue your science careers, these are things that you're going to get used to, things that are becoming more common. And so we're using this wireless probe here, and that is going to produce data on this graph, which you're going to need to reference for your lab report. If you look towards the bottom right hand corner of this, you can see the pH of our normal, or what we're going to call our normal ocean water, is about 5.7, maybe creep up to 5.6 if I move this around a little bit. All right, let's see what happens here. All right, about 5.57 is where we start at, and then rinse that probe off. Make sure to rinse your probes, folks, before you transfer solutions. Okay, and here is now the pH of the carbonated water, which you see drops quite a bit by about a full point on the pH scale, which remember is times 10, right? So our carbonated water is going to have 10 times the hydrogen ions inside of it. Remember, that's what it means as you go down the pH scale. All right. And so now we'll come back to our main solutions. Okay, and Mrs. V, I'm going to take it away with our...
All right, so we've got our model of our shells here. I've kind of broken them into little pieces just so we can see what happens. Remember, this is calcium carbonate. It's made out of baking soda. So it models what our shells would be made of. And we're going to put some into the regular salt water. Okay, what would it be? Salt water, and then some into the actual carbonated. So that's our dissolved carbon dioxide water. And we're going to see what happens to these poor little shells as this goes. Okay. So I'm going to put some into the regular salt water. You can see little bubbles. And then you can see what happens there with the ones with carbon dioxide. You see how much more bubbles as I put it in. That carbon dioxide caused it to happen. And when that does, that's what we get when we have so much carbon dioxide, it starts messing around with our shells. And you'll start seeing that's going to dissolve and kind of take away our shells much faster than our water. So when we talk about climate change, as we increase that CO2 in our atmosphere, that's more and more being dissolved into our ocean waters, causing it to almost be like this seltzer water, and that is what will happen to our shells, our coral reefs, our shells, and it'll completely change the ecosystem.
You guys can kind of see that, you know, we put in the same size chunks, and the chunks that are in our normal seawater, you know, have changed very little, right? You see no bubbles. You know, it looks pretty standard. And then, you know, if you look at the cup here, right, those are, you know, maybe half the size of the bits that we threw in, right? If you can compare one side to the other. So again, the one with the bubbles here is the carbonated water, and you know, as Mrs. V said, that takes a much more dramatic effect on anything, you know, that has that calcium carbonate in it.
Yes.
And just for comparison's sake, we can go back here to our graph. Okay, let me reset this. Things got a little wonky when I took the probe out. Oops. All right, and so again, here is our regular seawater. Okay, now another thing that you do notice is that as those things have dissolved on the bottom right corner, that our pH has gone up, right? Because that calcium carbonate is a little more basic, and so it will also alter the pH. But remember, that shouldn't be happening, right? Because the thing shouldn't be quite dissolving like that. So that jumped, I don't know, almost 2 on the pH scale, from about 5.8 up to now 7.8. Okay, let's rinse off our probe again. And now we're into the CO2 water, okay, which was in the 4s, about 4.5, 4.6, something like that to begin with. And you have the same sort of effect. Okay, it's jumped, it's kind of creeping down, but it's jumped about twofold on the pH scale, right? And again, that is due to those little chips dissolving, and then the solution will have a equilibrium dynamic that sort of takes place between the more acidic substance and the more basic substance, and then they'll be equivalent or equivalate out into the numbers that you guys see here. Okay, but
right.
Go ahead.
Yeah, and also note, you can say that it's coming back to a neutral solution, but remember, as we put CO2 in the atmosphere, it's continuing to dissolve back in the ocean. So it's continuing to drop that pH each time, even though these shells are dissolving. We're still going to add throughout the years as we go more CO2. So again, it drops it, they dissolve, they come back. It's just a cycle that keeps going.
So we can try that right now and see if it takes an effect. I have a straw here, and I'm just going to blow some air, right? You're exhaling CO2, so let's see what happens there. All right, and then we'll pull our graph back up and see what's happened to our pH. Okay, so yeah, it's gone down even a little bit more. Okay, so it went down about 0.2. Okay, and then now slowly starts to creep back up. But yeah, as Mrs. V said, the cycle just keeps continuing. So even if the little shells and corals and crabs break down, well, if you keep introducing CO2 into the environment or into the water, it's just going to further damage and alter the pH scale, which overall is not going to be good for anything living in the ocean, lakes or rivers, right? Because we talked about physiological pH, which is only around 7, so the further you kind of get away from that, the more damage that can be done.
And actually, if we can switch back, I'm going to pull up. Nope, there's still a little bit, but it's almost, these shells in this one are almost gone. Just because we have added so much CO2. If you think, like Mr. Herzog was doing, agitating it a bit, just like it would be on the ocean, right? And so you can think the more agitation, remember we talked about reaction rates, the more stirring sometimes, the higher that reaction starts to happen. Okay.
And look here, I mean, you can still see very large chunks in the normal seawater. Okay, whereas the chunks in the carbonated water, which they then further added more carbonation to, you know, is pretty well broke down at this point.
All right, so hopefully this little model helps you understand what will happen as we introduce and keep cycling CO2 into our oceans and what's going to happen to those shells. And think about if those animals can't grow and don't have shells to go to, what are they going to happen, right? You learned in biology all about ecosystems and those who, first producers, and then you got your consumers as you go higher. If we run out of the first level consumers or producers, what could happen to
Right,
the
which
whole ecosystem?
has some very dramatic impacts, and that's some of the things as you guys have watched some of the videos, and and probably read research of your own that sort of day by day we're seeing more of the ramifications of this. And so, anyway, hope you guys enjoyed our final stint. I know Mrs. V and I are happy to put a close to this. So
Yep.
make sure to finish your ed puzzle and then prepare for your final, which we'll have in a couple weeks. Okay.
Yep.
Bye, guys.
Bye, guys.